A solid consists of a right circular cone of height 120 centimeter and radius 60 centimeter, standing on a hemisphere of 60 centimeter, right? Is placed, okay, all of this is placed upright in a right circular cylinder full of water such that it touches the bottom. Okay, let me show you what exactly they're talking about. So we are looking at this. You have a cone on a hemisphere, right? So this structure is placed upright in a right circular cylinder. What does it mean? It means it is placed inside a cylinder like this. Okay, for better view, let me change the, yeah, it is like this, right? It's placed something like this. Okay, so apparently there was water inside this cylinder. So as and when you keep something, it comes out. So they're asking what is left out in the cylinder. Okay, provided the water is filled up to the brim. I hope you guys understood that it is filled to the top. Even after dipping it, they see to that the water is filled to the top. So they're asking what is the water remaining inside the structure. So pause and try to figure out the diagram. Write the given. So we are looking at two things over here. First is I want to do in this way. Let me change this. No, not that. Yeah. So first is I'll take two structures. One is the cylinder, right? Two separate diagrams that will be helpful. If not, it will be difficult. Even you guys can do the same in your exams. And then the cone in the hemisphere. Right? So a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter. So we are looking at, okay, this is what right circular cone. So we're looking at the cone of that of radius 60 centimeter and height. Okay, this is the bottom. And the height 120 centimeter. 120 centimeter. This is 60 centimeter. And hemisphere is also 60 centimeter. So this is good enough. You need not write more than this. It's placed upright in a right circle full of water such that it touches the bottom. Find the volume of the water left in the cylinder if the radius of the cylinder is. So we have radius of the cylinder and height of the cylinder given. So this is 180 centimeter and this is 60 centimeter. Right? Now we'll talk about given. So given dimension of cylinder is radius is 60 centimeter and height is 180 centimeter. Next is dimension of cone is radius is, okay, all the radius is the same. So I need not write it as R1, R2, 60 centimeter. But the height is different. So, H1, H2 will make sense. And last we have the cone, sorry, hemisphere, whose radius is 60 centimeter, right? Now we just have to find the volume of the water liquid left inside the container. That is nothing but volume of cylinder, obviously. Now the next thing is the tricky part. See, the thing is the volume of the water decreases once you keep this two. So we need to subtract them. Volume of the cone minus volume of the hemisphere, right? And so we have this to be equal to pi r square h1 minus pi r square h2 by 3 minus hemisphere, na 2 by 3 by r cube, right? So what is common in all of this? Pi r square. So what is left out? h1 minus h2 by 3 minus 2 by 3 r, right? Now it's just a matter of substituting and solving it. So this is 22 by 7 into radius is 60 everywhere. 60 into 60 into height is 180 minus 120 by 3 minus 2 by 3 into 60. Now a bit of calculation. One's 40s are, one's 20s are. So 80, 100, right? So this is 3.14 because we can't cancel anything. So 3600 into 100, right? So now we have to multiply this multiplication. So I've already done it. 336 into 3.14 is 113.04 into how many zeros? 1, 2, 3, 4 zeros. So many, right? 1130400 centimeter cube. So if I want to convert into meter cube, so 1 centimeter is 1 by 100 meter. 1 centimeter cube is 1 by 100 to the power of 3 meter cube, right? So basically this will be 1130400 divided by 123456 meter cube. So we have 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. So 1.1304 meter cube. This is your answer, right? So you can pause and have a look at the answer.